5.3, part 2. The first part, we started off in standard notation and we went to scientific. Now we're going to start off in scientific and go to standard. Okay. This says I'm going to be moving this decimal point 6 spots. Since this is a positive exponent here, this number is going to be getting bigger. When you first do this, when you're doing it by hand, chances are the first way you write it is going to be pretty ugly and you're going to want to rewrite it. So don't expect it to look very pretty at first. All right, 8.8. Now I need to move this decimal point 6 spots and I need to be making the number bigger, so I'm going to be moving it to the right. 1, 2, 3, 4, 5, 6 spots. Create your little bumps and then fill them in with zeros. So this is the same thing as 8,800,000. This one, I'm going to be moving my decimal point 9 spots. It's negative, so I'm going to be making it, moving my decimal point to the left to make this number smaller. Remember, like I said, these things are often ugly when you're first doing them. 9 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 0 point. I'm going to make myself little marks here so I can make sure I get them all written down. I'm breaking them up into little threes just visually. This is where it gets particularly useful to have scientific notation, because when you're dealing with numbers like this, we break them up into threes with commas, and it's easier to make sure that you've got them all. Generally, when we write decimals, we have no way of breaking them up, and it's very easy to lose one when you're doing that. When I'm writing out a long decimal by hand, I tend to exaggerate spaces between the three, but your calculator generally doesn't do that, and it's definitely not standard. Okay. All right, here's one that you can let be hard if you need to. I need to move how many decimal places? 0. Okay, well, I move it 0 decimal places. Negative 8.56. Nothing to that one. Don't let an easy problem throw you off. Okay. We talked in the last section about how something to the 0 power is 1. So this is just multiplying it by 1. And that's your answer. Okay. All right. We're going to do the arithmetic, and we're going to give our answer in both standard and scientific notations. Okay. Couple ways of doing this. You can use your power rules. You can multiply it all out and do the long, ugly arithmetic. It works. But this is all multiplication, right? And with multiplication, we can rearrange them however we want to. So I could do the 4 times the 3 times, and then I can do the 10 to the 7th times 10 to the 3rd. That works, right? Well, that would be 12 times 10. We have the same base. We're multiplying, so 10 to the 10th power. Okay. This isn't almost in scientific notation, but it's not quite. And the reason it's not is because my decimal point is right here, and I need only one digit in front that's not a 0. So I need to move it over one more. So really, this is like, say I moved it, let me go back up to this one. Let's say I moved it to right here instead of right here. Then I would have moved my decimal point 8 spots instead of 9. So to move it one more, I would have bumped it up to a 9. So I need to move this up one more spot. It's like I didn't quite move it enough. In scientific notation, this would be 1.2 times 10 to the 11th power. Okay. Now I can take this and I can rewrite it in standard notation. 1.2, and I need to move it 11 spots, making it big. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. okay? Now you could have done it that way, and these two would be your answers, or you could have transformed each of these. This would be 40 million times 3,000, which would give you, that would be the 12 with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. So you would get exactly the same answer.